In this video, we're going to model compound interest with an exponential function. So we have a setting with an investment account where interest compounds annually, and it grows according to this table. So everything we need to know is going to be built into this table. So our first thing we're going to try to do is figure out what our multiplier is. Exponential growth grows with a constant multiplier as x changes by the same amount. So if I want to figure out the multiplier, I would have 1800 times something equals 1854. Let me write that. So 1800 times something is 1854. So if I just look at this as an algebra equation, I can quickly see that if I divide both sides by 1800, I would get my multiplier. So I'm going to take 1854 and divide it by 1800. And I'm going to get 1.03. So I have a multiplier of 1.03. And I'm hoping that works here. Let's check, because that'll allow us then to fill in the other two missing values. So I'm going to do 1854 and times 1.03, and I get 1909.62, so that worked perfectly. Do it again, times 1.03. I get 1966.91. I'm going to round to the nearest hundredth to model dollars and cents. That was 1966.91, so that's this missing value. And then I'm going to multiply it by 1.03 again, and I get 2025.92. Okay, find the missing values in the table. We did that. What was the initial investment? That would be the value in the account at the start. So when x is 0, we had 1800. The multiplier we just figured out is 1.03. And so based on the multiplier, we can figure out what the interest rate is. And if I look at this, I have, thinking in terms of percents, this is 103%. As a multiplier, I could convert this to 103%. So it's like I have all my money at the end. I have 100%, but I've gained 3%. And that is my interest rate, 3%. And finally, we can write an equation that's based on the starting value, the initial investment, and this multiplier. And this is going to look very similar to what we've written for other exponential functions. We have our starting amount, 1800 in this case, and my multiplier is 1.03, and I'm going to raise that to the x power because I multiply by 1.03 x times to make it down to that row in the table. So that's what I would write here. And at this rate, what will the account be worth in 16 years? I'm going to plug in 16 for x. Let me write it out first. Y is 1800 times 1.03 to the sixth. So I can go to my calculator, and I can do that. 1800 times 1.03 raised to the sixth power. I'm sorry, 16th. I need to fix that on the page. 288.47. 2,888.47. And this was the 16th because I'm plugging in 16 years.